Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Fauzan Abdul Jalil. My metric number is DD170059 and my supervisor is Dr. Zaliha binti Muhammad. So for my presentation, my title is about a crab propagation simulation using Ansys for bamboo form composite. Then for the chapter 1, introduction. For the background study, we can see the structure of the bamboo and the cross section of the bamboo gum that have been shown in the figure. So bamboo is the type of natural fiber composite that is classified as stock fiber. So about the 70 genera of the bamboo and more than 1,450 bamboo species globally, of which 14 genera can be found in the tropical zone of Asia. Most primitive grasses, due to some of its characteristics such as the presence of the bracteates, interminate inflorescences and flowers with 3 glodycals, 6 stamen and 3 stigmata, consist of the cellulose fiber which are aligned along the length of the bamboo that give bamboo maximum tensile, flexural strength and rigidity. Many major industries have now searched for the composite materials such as concrete and so on. So the disadvantage of the for using the composite material is causing the environment problem like pollution and so on. So for conventional composite are non-renewable and non-recyclable. So the natural fiber composite have attract the interest of many companies as sustainable material. And the natural fiber composite has a high potential to substitute synthetic fiber, reinforce plastic at low cost and better sustainability. For example, that's why we take the bamboo as our material to be studied. So the objective of the experiment is to investigate the characteristic of the crab propagation for the bamboo form composite. Then to investigate the crack propagation trend for different type of specimen. Finally, to investigate the different criteria of the crack initiation. So for the chapter 2, for the literature review, I will discuss about natural fiber. So what is the natural fiber? Natural fiber is any hair-like raw material directly obtainable from an animal, vegetable or mineral source and convertible into non-woven fabrics such as flax or paper, or after spinning into yarn into the woven cloth. So a natural fiber may be further defined as an agglomeration of cell in which the diameter is negligible in comparison with the length. Although nature abound in the fibrous material, especially cellulosic types such as cotton, wood, grain, and straw, only a small number can be used for the textile products or another industrial purpose. So apart from the economic consideration, the usefulness of a fiber for the commercial purpose is determined by such properties as length, strength, pliability, elasticity, abrasion resistance, absorbency, and various surface properties. So most of textile fiber are slender, flexible, and relatively strong. They are elastic in that they stretch when put under the tension and then partially or completely return to their original length when the tension is removed. So for the crack propagation. What is the crack propagation? Crack propagation is the field of the mechanics concerned with the study of the fracture mechanics. It uses method of the analytical solid mechanics to calculate the driving force on the crack, and those of the experimental solid mechanics to characterize the material resistance of the fracture. It is important tool used to improve the performance of the mechanical component. It applies the physics of the stress and strain behavior of the material, in particular of the theories of the elasticity and plasticity, to microscopic crystallographic defect found in the real material in order to predict the microscopic mechanical behavior of those body. So Griffith is the one who made the theory for the crack propagation. Then Griffith specifically focused on the quasi-static propagation of the connected crack in a 2D linearly elastic, homogeneous, and isotropic medium, and he assumed that the crack part was known a priori, and it consisted in nice enough curve within the domain under the investigation. So there are three ways of applying a force to enable the crack to propagate. Firstly is the mode 1 fracture, or it's known as the opening mode. Second one is mode 2 fracture, or it's known as sliding mode, and then the third one is the mode 3 fracture, then it's known as steering mode. You can look at the figure how it was the shape of the crack was propagated. Then for the mode 1 is a tensile stress normal to the plane of the crack, while in the mode 2 for the sliding mode is a shear stress acting parallel to the plane of the crack and perpendicular to the crack front. Then lastly, the tearing mode for the mode 3 is a shear stress acting parallel to the plane of the crack and parallel to the crack front. So for the minimum strain energy density. So strain energy density factor as that can be used for the predicting the direction of the crack propagation and the onset of fracture in combined tensile and shear loading. So Erwin was the first to observe that if the size of the plastic zone around the crack is small compared to the size of the crack, the energy required to grow the crack will not be critically dependent on the state of stress that was the plastic zone at the crack tip. In other words, a purely elastic solution may be used to calculate the amount of energy available for fracture. So for the chapter 3, for the methodology, for the introduction is the experiment is apply quasi-static loading. Quasi-static loading is mean that the load is applied very steadily, that the system often deform quite slowly, that was very low rate of strain, so that the force of the inertia is very weak and can be overloaded. In another hand, a complex load allowed a system to vibrate and the force of the inertia is high enough and must be considered. So the experiment was conducted simulate by using Ansys software as the main medium to conduct the analysis for the crack propagation on bamboo composite form. So for the flow diagram that has been shown in the slide, we can look that it have two steps. First, while using SolidWorks, then finally the analysis will be done in Ansys program. So firstly, we have to create the model on the SolidWorks, model for the bamboo composite. Then we define the dimension of the geometry, and finally save it in IGE format. To it will import it to the NC program. Then when using the NC program is we have to set up the engineering data like the mechanical properties for the bamboo that want to be tested. Then we select the fracture option like fatigue analysis, stress analysis, and so on. Then we apply the loads and the fixed support. We put the load on the part that want to be cracked. Then select the fracture criteria needed, like a stress intensity factor and the minimum density and minimum strain energy density. Then finally we run the analysis. Then we get the data and to create the result and the discussion of it. So that's all from me for the presentation for the PSM1.